All right, welcome back to the last example from our Transformations Day 2 notes. We are now looking at the graph of g that is doing these transformations, and what we're starting with is the parent function x squared. So that tells me that my vertex should start at 0, 0. So my first transformation is a translation 6 units down. So that means that my vertex should move to 0, negative 6. In order to reflect that within my function, I'm going to do x squared minus 6, which does track with where my vertex should be. Our next transformation is we want to go 8 units to the left. So that means that my vertex is going to move to negative 8, negative 6. And to reflect that within my function, I need x plus 8 inside my parentheses. This is vertex form. So if this is x minus h, that tells me h is negative 8, k is negative 6. So we're in the right spot. We've done our first two transformations. The last thing we want to do is a horizontal stretch by a factor of 2. So what this means is we are going to double our x-coordinate, and our vertex is going to move to negative 16, negative 6. Now to reflect that inside my function, remember we're always doing the reciprocals when it comes to our horizontal dilations. So what is going to happen inside my function is I'm going to replace x with 1/2 x. And now I am no longer in vertex form. I'm in that other form that we have been talking about. And to double check where my vertex should be, I need to divide c by b. So if this is plus 8, that tells me that c is negative 8. And our b value is 1/2. Negative 8 divided by 1/2 is negative 16. My d value is negative 6. So my vertex is in the right spot. And our new transformed function will be 1/2 x plus 8 squared minus 6. Now, suppose the horizontal, and that should say stretch, was performed first, and then our translations, our shifts left and down. So we're still starting with our parent function, the vertex at 0, 0. And if I do the horizontal stretch, that means I'm doubling my x-coordinate. Well, 0 times 0 is still 0, so it's not going to change the location of my vertex, but it will change my function. To represent that within my function, I'm going to have to do 1/2 x squared. Again, you do the reciprocal when it comes to your horizontal dilations. Then we are going to do our two shifts. So we went 6 units down. I want to be at 0, negative 6. I reflect that in my function by subtracting 6. This is still vertex form, so we have 0, negative 6. Great. And then now when we do 8 units to the left, we want to make sure our vertex ends at negative 8, negative 6. So within my function, what I'm going to have to do, 1/2 x, when you're going to the left, it's x plus that number. And when I distribute this 1/2, I'm going to get 1/2 x plus 4 squared minus 6. Now let's make sure this put our vertex in the correct spot. C divided by b. If this is plus 4, that tells me b was negative 4. Sorry, c was negative 4. Divided by 1/2. Negative 4 divided by 1/2 is negative 8. My d value is still negative 6. So our vertex is in the right spot, and this would be our g function. 1/2 x plus 4 squared minus 6. So again, the order you do the operations of your transformations matters. So make sure you're reading very carefully in the order it says. That concludes our Day 2 notes on transformations.